Alright, well, as promised, I told you guys we're going to start out this next lesson with just going back and trying one more time and just practicing again on how to solve a system of two equations using matrices and specifically doing it by hand. So I just picked out an example real quick. We wanted to solve 3x plus y equals 1 and in conjunction with negative 7x minus 2y equals negative 1. Okay, so if we're going to do matrices, remember what we want to first check is to make sure everything's in the correct order. We have all of our x's and y's equals a constant. X, y equals a constant. So it looks like these two are set up exactly how we need it. So let's go ahead and create our first matrix. First column, remember, is all the coefficients on the x. So 3 and negative 7. Next column on y's. So 1 and negative 2. Draw my bar for my equal signs and 1 and negative 1. Okay. Well, like before, we always start out, we want that position right there to be a 1. So we're going to take that row, which is row 1, and we want to divide it by whatever is sitting there. So we're going to divide it by 3. Okay. And let's create this brand new matrix where just row 1 is divided by 3. So we'll get 1, 1/3, and again 1/3. And then row 2 just stays the same because all we're doing is affecting one row at a time. Okay. That's done. Next thing we want to do is put a 0 in that position. Right? To make a 0, we're going to go above it to row 1, multiply it by the opposite of what's sitting here. So the opposite of negative 7 is positive 7. And then what we're wanting to change is row 2, so we're going to add it down to row 2. Okay, so row 1 is going to stay the same. We have 1, 1/3, and again 1/3. And now row 2, to get the brand new row 2. Everything in row 1 is going to get multiplied by 7. So if I kind of put an imaginary little 7 out here. Okay, so 7 times 1 is 7, and 7 minus 7 is 0. That's great. That was just doing that to that and adding it down. Sorry, so 7 times 1/3. So we're going to do 7 times 1/3 and then go minus 2. So that's 7/3 minus 2, which is 6/3, right? So 7/3 minus 6/3 is 1/3. So I'm going to put a 1/3 down there. Alright, go into the last part. That says 7 times 1/3 and then minus 1. Or 7/3 minus 3/3, which is 4/3. Okay, so looks like if we look at that matrix so far, over there on the top right, that everything looks good. We have our 1 checked off in the top left. We have the 0 below it, so now we need to come to that position right there and make that a positive 1. So we can do one of two things. If I multiply that position like right there by 3, then I'll get a 1. Okay. Or I could divide that whole row by 1/3. Multiplying by 3 and dividing by 1/3 is the exact same thing. Just to make it easy, I'm just going to go row 2 and I'm going to multiply it by 3. Again, that's the exact same thing as dividing by 1/3. But it seems a little easier. Okay, row 1, exact staying the same. Okay, if I go 0 times 3, it's still 0. 1/3 times 3, well, 1/3 of 3 is 1. And then 4/3 times 3. That would be 12 over 3, which is 4. Alright, so things are looking pretty good. Last but not least, we just need that right there to be a 0. So I'm going to go to row 2, multiply it by the opposite of what's sitting there, which is a negative 1/3, and add it up to row 1 because row 1's where the 0 is going to go into. So we're leaving row 2 the way it is. Okay, so here we go. We're going to go negative 1/3 times 0, which is 0, plus 1, 1. Negative 1/3 times 1 is negative 1/3, plus positive 1/3 is 0. That's good. And negative 1/3 times 4 plus 1/3. Well, okay, that's saying a negative 4/3 plus 1/3. So negative 4 plus 1 is negative 3 over 3. Negative 3 divided by 3 is a negative 1. And once we finish right there, we have our answer, because that first row is telling me that x equals negative 1. The second row is telling me that y equals 4. And let's go back and check. Let's make sure we get this answer right. Let's go back to our original equations up here. Let's see, 3 times negative 1 plus 4. Well, negative 3 plus 4 equals 1, so that checks off. Let's come down to the second one. Negative 7 times negative 1 minus 2 times 4. Okay, so that's saying basically 7 minus 8, which is negative 1, and that one checks off. So our answer either as x equals negative 1, y equals 4, if we want to write it in coordinate forms. Remember, this is where those two lines are crossing, and that'll be my answer, specifically using us matrices and solving it by hand. Okay, so let's jump into where this lesson's really taking us in sections 5.3, 5.4, and 5.5 in the book. And what we're doing is just kind of starting on how to interpret answers. Meaning, if I go in, I put a matrix into a calculator, and I have it do that RREF and spit out an answer, let's do a little more practice on actually interpreting those answers. Okay? So far, everything we've looked at has been pretty simple. We just go across the rows, right? The first row is like x equals or x1. Second row is y equals or x2, and third row, and so on, okay? And that gives us our x equals this, y equals this, z equals this. And it's been pretty straightforward, but there are going to be some special circumstances, and this is where we're starting out right here. So with example 1 here, these are what it would look like if you have exactly one solution. And like I said, this is what I was talking about. If I go across this first row right here and just read it out, it's saying, all right, x equals negative 2, okay, 0x, so 1y is equal to 1. There's no x's, no y's, so right there, z is equal to 3. Well, all of this together as one big unit, that's really one solution. Remember, this is where those three equations are crossing, and it's crossing at this coordinate. We're graphing in 3 dimensions, but it's crossing at that coordinate. And there's just one solution. If I go to this next one, it's saying x equals 5. The second row is telling me 0x, so y is equal to negative 2. And this third row isn't really giving me anything. It just says 0 equals 0. That's true, but it's not really giving us any answers. And so my solution to this one would be just 5, negative 2. Okay, and there again, it's just one answer. Here, just one answer. Now, what would it have to look like to get no solution? Well, again, just read it off. This first row says x equals 4. This second row right here says y equals negative 1. This third row, however, this is where the special case is coming in, right here on this third row, because it's saying 0x, 0y, 0z. So in other words, 0 equals negative 3. Well, when in the real world has 0 ever equaled negative 3? Because of this right here, that fact right there, that's what's causing, because that's false, that's what's causing really the no solution. It's because of that last row. Okay, so definitely something you have to watch out for when you're going through this process. And then what examples of infinite solutions looks like. Well, let's look at this first row. It says x, 0y, and z. So x plus z is equal to negative 1. The second row says no x's but y is equal to 3. It's infinite solutions because we don't really know what z equals. All we know is that x plus z together have to be negative 1. For sure, y has to be 3. So if you kind of want to write this as a coordinate form, what you might do is come over here. Write this as x is going to be negative 1 minus z, y has to be 3, and then really z can be any number. And what we do is we do this r with a double bar for that, and that represents, that's a shorthand for that right there. Let me write this out like this. That's just a quick way in math to represent any real number. So you don't want to have to write all this out every single time. You can just do that r with a double bar through that, and that represents any real number. Because really what you can think about it is, can you tell me all the different coordinates where as long as y is 3, so just think about it, you have an x, a y, and a z. I know for a fact that y has to be 3, but all I know about x and z is they have to add up to negative 1. So like x could be 0 and z could be negative 1. X could be 4 and z could be negative 5. There's an infinite number of pairings that add up to negative 1. That's why this is an infinite solution. And so how you'll see this written is like this. You'll see it as negative 1 minus z right here in the x spot, because that's what we just said, x equals that. And then z right here, you can just put like all real numbers or something like that. Okay, let's go to this second one right here. Go across the first row. These are my x's, y's, z's. Oh, I guess we can make it mean w for our fourth variable. So this first row, all that's saying with all those zeros in there is just x equals 3. Second row is y plus z is equal to -1. And third row says w equals 2. So again, kind of like above, we know what x is, that's given. Y, or w for sure is 2. But y plus z, they're both just have to be any combination that adds up to -1. So whenever this happens, just choose. Solve one for the other. So say y is going to be -1 minus z. And whichever one you put here on that right side, that's the one where you're going to say z can be all real numbers. So in a big coordinate form, x is 3, y is -1 minus z, z is all real numbers, and then w was 2. So there's x, there's y's, there's z's, and there's w's. Okay? And that's how you kind of handle the infinite solutions. Alright, let's go to example 1. We want to solve the following system using a calculator. So real quick, just going through here, just checking x, y number, x, y number, x, y number. Looks good. So we're ready to set this up. We're going to come in here, 3, 2, 1. There's all my x's. All my y's are -2, 1, -2, equals -3, 3, and -5. Okay, so if we look at this, the dimensions of this matrix looks like it's a 3 by 3, right? We have 3 rows, 3 columns. So why don't we pause this video real quick. Y'all put this matrix in your calculator. Ask your calculator to do the RREF, and let's check our answers when we come back together. Okay, and I just put that in real quick into my calculator, making sure that when I did the -2, it was actually a -2, not a -2. Used the right button there. And what came out was this system of equations, or this row matrix. And remember, your calculator won't show you that vertical line right there, but just know that it's always going to be right before your last column. Okay, and let's interpret this. So that first row basically says x equals 0. Does x? Remember, your x's, your y's, and that's what they equal. Okay, so x equals 0. The second one is saying y equals 0, and then that third row is saying 0 equals 1. Well, look at that. 0 can never equal 1. So because of that right there, my answer for the whole thing is actually no solution. Okay, and again, interpreting what this means is if I come back up here and I wanted to graph those 3 lines right there, and in order to find a solution, we're looking to see where they intersect. Well, because there's no solution, that means there's no one point where all 3 of these cross. Now, I could have 2 of them crossing, but the point is you need all 3 crossing at exactly one point. If you wanted to draw this, you could have one coming up like this, another coming down like that, and I could even have a third one coming across like this, but so, there's intersections points here, here, and here, but there's no one point where all 3 are crossing at the exact same thing. So therefore, there's no solution to this whole system as one. Okay? That's what we're looking for whenever we're doing this. But